My name is Gilbert C. Mariano, and my part is introduction. And our topic for today is Doppler shift from theory to technology using simulation. And before we start, I'm going to click the start, and we have three parts: information, simulation, and back. I'm going to click the information.
Good afternoon. Today, I will now proceed to the introduction. We'll investigate the Doppler effect, a phenomenon where the observed frequency of a wave changes depending on the relative motion between the source and the observer. A PowerPoint presentation will provide a deeper understanding and a visual simulation to grasp the fundamental concept. Click the buttons for more information. Now, we'll proceed to the definition. So, the definition of the Doppler effect is the shift in the frequency of a wave in relation to an observer due to relative motion of the wave source and observer. Now, let's proceed to the theory. So, the theory of the Doppler effect is the change in wave frequency due to the relative motion between the source and the observer. If the source moves closer, the frequency increases. If the moves away, the frequency decreases.
Okay, so let's now move to application. First off is medicine. Ultrasound to image blood flow in vessels. Next up, speed guns. Police use radar guns or laser speed guns that emit radio waves or say laser seismology. Analyzing the frequency shifts help determine earthquake magnitudes and its location. So, let's move on to conclusion.
Our last part is conclusion. The Doppler effect's principle of frequency shift analyzed finds crucial application in diverse fields, including medicine, they use ultrasound, speed detection, radar or laser, earthquake analysis, and astronomy, analyzing celestial bodies. Its versatility highlights its fundamental importance scientific measurement and technological advancement.
Hi, this is Sandra Pamini, and I'm going to show you our simulation. As you can see, there's a guy right here, okay? Now, you can actually interact with him by clicking all those buttons. Now, let's go left, he can go right, and stuff like that. Now, him changing position is actually one way to simulate the Doppler effect, depending on where our observer is going to stand and where the sound is going to come from. Now we also have start car, ride car, and return. Of course, start car will pretty much just start the car, while ride car put our character in a car. Now, of course, this will give a different sounds because inside the car. And of course, return to put him back to the ground. Alright, let's start the simulation, and I'll explain it afterwards. That is the sound of the car when our characters is at the starting point. Now let's put him in the middle to get a different sound. Now lastly, we're going to put our observer in the car. As you can see, our sounds of the car is changing because of the observer is changing its places. As you can see, the frequency of the sound gets higher and gets lower depending where the observer is standing. But now he's on the car. The sound it's constant. It's not changing because he's with the car. Now, just to make sure if you understand anything, we'd like to ask you some question about our presentation, just to make sure.
Proceed to the questions. Yes, sir.
Yes.
I have a question for you.
Ano po yan?
So, what is Doppler effect for you?
Nasaan po yun natin. For example po, di ba, merong kotse na papass by, tapos nabubusina. Or ambulance, much better po yun. Tapos nag-ano po siya ng wang-wang-wang, di ba? Narinig niyo po yung sound niya, parang very tapos when it pass by, very loud. Tapos pag lumagpas po, parang narinig po na lumalayo at humihina yung di ba? Nag-change yung pitch. So yun po yung ko po ng Doppler effect. Thank you po.
Okay, for the next question, Doppler shift.
In medicine, I think it's used in the sound and the police. It used in the radar and the seismology. It's used as the determining the magnitude in earthquake.